Hello and welcome to another tutorial. I'm Mr.Muhammed and this is Revise for Checkpoint book. In this tutorial, our objective is gradient and intercept. Gradient and intercept is very important, and today we're going to work on them in an algebraic way, because we can also work with gradient and intercept on the graph, but today we are going to talk about the algebraic way. The most important thing for this tutorial is the standard form of linear equation y equals mx plus c. This is called the standard form when you have y all alone on a side, x and the constant on the other side. This number, which is right in front of x, is the gradient, and this constant will be the intercept. Intercept means when you graph the equation, where the graph crosses y-axis, this place, this point is called intercept, and sometimes it's called y-intercept. It means where the graph crosses y-axis. Check your understanding 18.3. Here we have some questions. The equations are not in the standard form, then we need to write them in the form of y equals mx plus c. Then once we did this, we will be able to see the gradient and the intercept. The first question in this set is question 1a. Question 1a, y minus 3x minus 4 equals 0. Okay, all you have to do to keep y all alone on the side and everything else to the other side. So we can do it by sending these to the other side, and whenever you send a term or a number to the other side, the sign will be changed. Like when it's negative, it will be positive. When it's positive, it will be negative. Now here we send these two terms to the other side, and they both negative, they will be positive. What's remaining here on the left side is just y equals negative 3x will be positive 3x, minus 4 will be plus 4. Now we have y in the form of, we have the equation in the form of y equals mx plus c, and m is the gradient, c is the intercept. So for question 1a, the gradient m is 3 and c, which is the intercept, is equal to positive 4. Now let's do question 2. Question 1b. Question 2. Question 1b, y over 3 minus x equals 0. Okay, then firstly we need to send this x to the other side. That will be positive x. Then y over 3 equals x. But as you see, we don't have y alone on the side, it's y over 3. Then how can we remove this 3? The relation between y and this 3 is division. What's the opposite of division? Multiplication. So we multiply everything by 3 to remove this 3 under the y. Then y over 3 times 3 will be y equals 3x. So y is equal to 3x. Done. The gradient is 3, but what is the intercept? Here, the intercept is 0 because it is 3x plus 0, but the 0 doesn't appear because it has no value. Then the gradient for question 1b, m, which is the gradient, or sometimes it's named g, both fine. Then m is 3 and c, which is the intercept, is 0. Now question 1c is your homework. Question 1c is your task. Do it on your own and comment below if you have any difficulty or any question. Now let's move on to question 2. Question 2a, 3y minus 6x equals 4. Okay, now how can we have y alone on a side? So when you see y all alone on a side, it means y is the subject. Any variable, when it's alone on a side, it means this variable is the subject. Now we can say, how can we make this y the subject of this equation? Means y must be alone on the side. Then firstly, we send the 6x, we get rid of this negative 6x to the other side, it will be positive, and 3y equals 6x plus 4. It's okay to write 4 plus 6x, but according to the standard form, it's better to write 6x plus 4. Then we need to get rid of this 3 to have y alone on this side. So the most common mistake for such questions, students, when they see something like this, it looks like mx plus c, straight away they say the gradient is 6. No, because y is still not alone on the side. We cannot say the gradient is 6. Then how can we remove this 3? We divide everything by 3. Then it will be like this. 3 divided 3 is 1, so what's remaining here is only y. 6 divided 3 is 2x plus 4 divided 3, we can just leave it like this, 4 over 3. Now for question 2a, m, which is the gradient, is 2 and c is 4 over 3. Can we write c as a mixed number, 1 and 1 over 3? Yes, it's okay. Or as decimal, it will be 1.3 and the 3 is repeating. 4 over 3 as decimal is 1.3 and the 3 is repeating, so it's a recurring decimal number. But this fraction is okay. Now we got the answer. Let's do question 2c. Question 2b is your task. (2b) is your task, so let's start 2c. 2c, 3x plus 2y equals 12. Now this 3x will go to the other side, will be negative. So 2y equals 12 minus 3x. Now to get rid of this 2, we need to divide everything by 2. But before we do that, let's organize this to look like the standard form. Negative 3x plus 12, because the 12 is positive and the 3x is negative. On the side, 2y. Then divide everything by 2. Y equals negative 3 over 2x plus 12 divided 2 is 6. So for question 2c, the gradient is negative 3 over 2 and the y-intercept is 6. Can we write negative 3 over 2 like this? Yes, we can. It's okay. They are equivalent. And c is equal to 6. Question 3a is your task, because part A is the easiest in question 3. And let's do part B and C. In part B, as you see, the y is negative. So I'm going to tell you how can you remove this negative to have y all alone on the left side and everything else on the other side. Question 3b. 3x minus 4y plus 5 equals 0. Okay, then how can we have y alone on a side? Firstly, we send this 2 to the other side, they will be negative. So now what's remaining here is negative 4y equals negative 3x minus 5. Now how can we remove this negative? Whenever you needed to remove a negative, so simply multiply everything by negative 1, because negative times negative is positive. Then negative 4y times negative 1, it will be positive 4y equals positive 3x, because it's negative, times negative 1 will be positive, plus 5. Now how can we remove this 4? Divide everything by 4. Then 4 divided 4 is 1. What's remaining here is only y equals 3 over 4x plus 5 over 4. Then for question 3 part B, the gradient is 3 over 4 and the intercept is 5 over 4. Question 3 part C. Question 3C. 3C, 4x plus 3y minus 1 equals 0. Then 4x with negative 1, they go to the other side. 4x will be negative 4x. So what's remaining on the side is 3y equals negative 4x plus 1. Negative 4x plus 1. Now, to remove this 3, divide everything by 3. Then it will be like this. 3y divided 3 is just y equals negative 4 over 3x plus 1 over 3. So finally, the gradient is negative 4 over 3 and the intercept is 1 over 3. So check your understanding. 18.3 is done. Now let's move on to modeling real life problems. Here is a very good worked example. Now this question is a very nice question. A van hire firm has two price plans. Plan A is C, which stands for the costs, equals 40 plus 0.4 times n. N is number of kilometers. Plan B is C equals 100 plus 0.25 times n. Then C is the cost, n is number of kilometers. Okay, we have two line graphs here. And part A says state which plan corresponds to the red line. So this is where we need the intercept. Which plan corresponds to the red line? Red line has the y-intercept. The y-intercept of the red line, it means where the red line crosses y-axis. The red line crosses y-axis on 100. So which equation contains 100 as a constant? So the red line is for plan B. The answer is plan B. Now, part B. Martha drove 500 kilometers. Which plan should she use? 500 kilometers is right here. So which plan is cheaper? Plan B is cheaper for her. Because she drove 500 kilometers, she have to use plan B because plan B has less cost than plan A. So the answer of part B is B. Now, Fred drove X kilometers. We don't know how many kilometers. We don't know. But what's the clue to find it? Fred drove X kilometers and found the price was the same under both plans. Find the value of X. Then look at the graph. In which point both plans have the exact same cost. So from here all the way to 400, the blue plan, plan A, is cheaper than plan B. And in this point, the plans are exactly equal. They both equal to 200. So it means Fred drove 400 kilometers. The value of X is 400 kilometers. I hope you find it easy. Comment below whatever question you have. Thank you for watching.